I will be going over the homework, which is completed on code.org, for representing images uh, using just black and white pixels. So, like I said previously, on a computer, everything is represented in just zeros and ones, whether it be text, whether it be any other types of numbers like base 10 numbers, or images. So today we're going to take a look at how we can use zeros and ones to encode just black and white, simple black and white images. So the contents of this assignment includes a activity guide, which is linked here, and that's your own copy. So when you open it up, it should look like that. And it also includes doing stuff on code.org. So if you click on this link, it will take you directly to puzzle 3 of 10. The previous links in our lessons in code.org include a video that you can watch at your leisure and just the lesson overview that has the links to our graphic organizer and such. So let's go ahead and get started. So in the first exercise, this has nothing to do with the activity guide yet. So once we get there, I'll pull that up. But for this first one, we simply want to get acquainted with using what's called the pixelation widget. And so what we're going to do with this pixelation widget is we're going to try to replicate the image of this A here. And what's a little annoying is that this is actually going to go away as soon as I click OK. So I'm just going to take a screenshot of that so that I can have that up and ready. It says here that I'll need to use sliders to set the correct dimensions. And what they mean is the width, so how many pixels across, and how high, so the height, how many pixels high. So okay, I'm going to click on OK, and I'm actually going to just kind of pretend like I haven't done this already. Okay, so at the beginning, I believe it won't even really have these set here. So we can adjust the image width and height, so we can see that this is 3 high. So we can use the sliders, or we can simply put the number in here. So 3 pixels wide, and then we've got 5 high. So we can go ahead and put 5 there. So now we have the correct dimensions here. And we don't want this in hexadecimal, make sure it's in binary, because we're just using binary and we haven't learned about hexadecimal yet. Okay, so we want to replicate this image here. So remember, in binary, we just have ones and zeros. So if I put a 1 here, you can think of that as turning on a light, and so it's going to be white. If I put a 0, it's going to be off or completely dark or black. So I want to kind of follow the pattern here. So already I kind of see like I'm kind of copying that. So 1, 0, 1. And then for the next row, I have black, white, black. So I want 0, 1, 0. And then the next row right here, I have all black. So 0, 0, 0. So I'm seeing here that each of these pixels is 1 bit, right? One number. So one binary number is 1 bit. And then for the next row, I see black, white, black. So that's 0, 1, 0. And then the last row is the same thing, 0, 1, 0. Okay, so we have successfully used binary to encode color of different pixels in an image. So each of these squares is a pixel. Okay, cool. So you can save this image if you enjoy your art, or go ahead and click on Finished. Continue to the next step. Okay, so for this next puzzle, we are given the task of doing some debugging. So the intended image is supposed to look like the C in the code.org logo. But as we'll see, if I go ahead and refresh this, so as we'll see, when I look at this, it's going to look a little messed up. So this is what it's supposed to look like, and it's not quite there, right? So if I'm looking at this row by row, I'm seeing that it matches up until here, and then here, let's see, black, 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 black. It looks like there needs to be another black. Or no, I'm looking at here. So black, 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 black. So this row is actually okay too. And then this next row right here looks like that might be the problem. So I'm seeing that there should be 3 blacks here, and instead I have black, black, and then white. So maybe this isn't supposed to be here. So I'm gonna look at row 1, 2, 3, 4, 5, 6, and I'm gonna look at that third bit. So 1, 2, 3, 4, 5, 6, and here's my third bit here. I'm just gonna try erasing that guy. And now you see all of those bits kind of shift over back into place. And that's what I actually want. So that's all we have to do here. This is just kind of doing a little debugging. And notice how like the numbers don't align in a nice, easy to read fashion. The computer doesn't really care, but we might care. So there's this readable format button that we can click, and now everything kind of aligns. And notice how you can actually see the outline of that C character, right? Because that's all the white pixels, all the ones. And you can see the white edges here too are the ones as well. Okay, so let's move on. So in this next one, we are actually going to start up with the graphic organizer. So if we open this up, we are going to see that we want to work to digitally represent this image using sampling. So we need to reference our activity guide. Okay, what the heck is sampling? So sampling means that we're going to look at an image and we're going to break it up into discrete pieces, into basically pixels. And what we want to do is we want to make a decision about each of these pixels. Do we want it to be white or do we want it to be black? So if you'll notice, this one is a pretty easy decision. Like this is all white. But then these ones in the middle here, we have like a mixture of some black and some white. So we're going to have to make a decision based on, kind of our logic here. So this process of looking at each individual, well, first of all, just breaking everything up into discrete pieces, into pixels, and then making a decision on what color we should represent that pixel with is called sampling. Okay, so what we're going to do is we're going to click OK, and I'm going to go ahead and pretend like I didn't do this. And the first step is to look at how many samples are we doing? So what is the dimension? So we see 1, 2, 3, 4, 5, 6 pixels across. So we want to set our image width to 6. And then we see that there's 8 pixels high. So we want to set that image width to 8. Okay. Next thing is I'm going to go ahead and kind of annotate on this guy. So let's see if I can do this. Okay, so I'm going to kind of write on each pixel, each square, what color I kind of think would be the best to make it. So I'm going to go ahead and put a text box here over the picture. And then we will also highlight it so that we'll even see it over the black parts. Okay, so this first one is quite easy because we see it's all white. So I'm going to decide to make that white, which is 1. And then the next one is a little bit more white than black, so I'll decide to make that white as well. This one is mostly black, so let's do black. And then this next square is mostly black as well. This one's mostly white, and then the last one is completely white, so okay, so now what does this mean? We're going to take these numbers and we're going to then put them into the pixelation widget, and then we'll see the colors pop up on this first row. So for this first row, we have 1, 1, 0, 0, 1, 1. Okay, so it doesn't look exactly, like this picture, because this is the effect of sampling. We have to decide on one color for this pixel. We can't have, you know, this level of precision that we see in the original image. All right, so for the next row here, I think that white, black, white, white, black, and then white would be a good decision. So we'll transfer that over to the pixelation widget. We can kind of see kind of like the goose head curving like that. And the next one we'll do black, and then this one's kind of hard, but perhaps we'll say white, 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 and then white. And you know, could have chose black for that too. It could have gone either way, so yours might vary. If you're making decisions that are different than mine, that's totally fine, as long as it's, you know, a rational decision. I wouldn't put black here for a pixel that is completely white, but I could definitely see how you might put black for this one, since it's almost half and half. And then for this one, maybe black, black, white, white, black, and then I think this one could go really either way, but I think I want to put black so I kind of have that that tail there. So I'm going to put 0, 0, 1, 1, 0, 0. All right, and for the next row, I think I'll go black. You might choose white for that, that's totally fine. So I'm going to just put black, 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 and then end with white. Okay, and then for our next one, oops, I put too many numbers there. Okay, there we go. And now for the next one, we're gonna do white, and then yeah, this one's almost exactly half, but I think I'll put, I kind of want a curve happening there, so I think I'll put white, black, black, white, and then white. So we'll put 1, 1, 0, 0, 1, 1. Kind of a funny looking goose, but that's okay. And then we're gonna get to the legs here. So we're gonna have white, and then, so really this is mostly white, but maybe you'll decide to put 0 here so that you could at least have some of the leg there, and perhaps the same for this one here, and maybe white for this one. Or maybe you'll choose to have white here and then black here. It's really up to you. Make the best decision based on the color there, and maybe like kind of thinking about what the picture is also. So maybe we have the legs, and then finally we have the feet down here. So maybe I'll put white and then black for that foot. White, white, black, and then white. All right, so not the best replication by far. You can kind of see the curve of the neck and then kind of like the tail here. But it doesn't, if you told me this was a goose, or if you just showed this to me, I probably wouldn't guess it's a goose. So now let's go back to our graphic organizer. So now that we've completed challenge A, which was trying to replicate this with a limited number of sampling, so 6 by 8, that's what, 48 different samples, 48 different pixels, right? So in essence also 48 bits, right? Because we have 1 bit per pixel. We see that the representation is not very good, because this is a relatively low number of samples. The pixels are very huge. They take up a lot of space in the original image, and so this is going to be a lower resolution image that is lower quality. So again, how many total bits were needed? Well, since it's 1 bit per pixel and we have 6 pixels across and 8 down, it's going to be 48 bits. And then how long did it take? How long about did it take? Well, probably about 5 to 10 minutes. We'll put 5 minutes. And how does the digital image resemble this one? So again, this is the digital image, and this is the original image. So the digital image is almost is pretty unrecognizable when comparing to the original. This may be because of the low sampling rate. The image we created is very low resolution and is lower in quality. Right? We're limiting the amount of data that we are using to represent this more complicated image, right? So we don't get all of these curves and nuances in the original image because we're limited to 1 color per pixel here. Maybe if we had, well, not to say that it's because it's 1 color per pixel, but because we have a very limited number of pixels for this amount of space. So if we had more pixels, then maybe we could make a better image. And guess what? Our next challenge is to do just that. So now we're going to sample more frequently by reading the image using smaller squares. So we're going to have more squares, more pixels. So in this next one, I believe we double the amount of pixels. So instead of 6 by 8, it's going to be 12 by 16. So we can go ahead and go to the next stage where we see this. And so now on this one, we will have to set the image width to 12 by 16. Oops, 16. All right, so we're going to go through the same process. We're going to make decisions about each of these squares, if it's going to be white or black. All right, so for our first block, it's definitely going to be white. And then we've got white, 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 and here's where we start making decisions. So I think white here, and then this one, I think we'll go black, 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 white, 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 and then white. And you may have made some different decisions about these ones in the middle, since they could have gone either way. That's totally fine. But I'm going to go ahead and transfer my numbers in, and that's what I have for my first row. The next one, I'm going to say white, 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 black, black, oops, black, 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 and then the rest white. Then we'll go ahead and transfer those over. So 1, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1, 1. All right. And for the next row, we're gonna wind up with 1, 1, black, black. This one could go either way, but I think I'll go black and then white, and then you could really go either way with this one too. I will go ahead and go white, black, black. This one could go either way, but let's go white, white, and then white. So 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 1. Okay. So we're kind of seeing the curve of that goose's neck. We're seeing more of a curve than we did in the last one, which was very, very blocky. Again, because we are increasing the frequency of our sampling. Okay, so white, and then This one could go either way. I'll do black, and then black, and then perhaps white, 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 and then black, black, white, and then white. Transfer those over. 1 0 0 1 1 1 1 1 0 0 1 1. Okay, and then for our next row, we're gonna do white, black, black, and then I believe just white the whole way through after that. So 1 0 0, and then a bunch of ones. And then for this next one, we can do, you'd either do black or white there. I'll do white and then black, and then black, and then white the whole way through. You might choose to do black here. I'm gonna keep it as a white value. So white, black, 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 oh no, black, black, white, 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 white. Alright, so that kind of looks like a goose head, kind of. Like at least a lot more than the last one. Okay, so I'll kind of continue this trend of white, black, and then black. I'll keep that white, 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 white. This one I'll do black, and this one I'll do black, and then white. Okay, 1 0 0 1 1 1 1 1 1 0 0 1. Alright, so now we have the beginning of the tail up there. Alright, next one. You might want to do black here, just so that there's a little curve. Continue with blacks, and then you could go black or white here. I think I'll do black, white, black, but you might make a different decision, which is totally fine, since it could go either way. Alright, so now I've got 0 0 0 0 0 1 0 0 0 0 0 1. Okay, so now I've got kind of like that curve. We've got kind of trying to represent that curve of the goose's back there. It's going to look a little blocky though. Alright, so white, and then I believe blacks all the way up until the end, with the final white at the end. Okay, so we're just going to fill that with zeros until the end. Okay, looks all right. And then the next one, white, we'll continue with the blacks until we hit those last two. Alright, so white, and then all blacks until the last two. Okay, and then going to the next row, we will have white, white, and then we can have black, black, black up until maybe the last three there this time. Alright, go up until the last three. So now you kind of see the goose's body kind of curving, as we do in the original image. Alright, we'll do white, white, white. This one will be white, and then these four will be black, and then the rest will be white. Okay, so we've got 4 white, 4 black, and then 4 white. Now we're getting to the legs, which might look a little, well, let's see how it works out. So white, white, white. Again, we can go either way on these. Technically, they're mostly white, but we do want, you know, the legs to appear, so let's make those black. This one's mostly black. So let's see how that turns out. It might make the left leg look a little weird because it's technically taking up 2 pixels, unlike the right leg. But, you know, that's the effect of sampling. So let's just see how it turns out. Alright, so the next one we're going to do white, white, white. This one's black. The middle 4 are going to be white. This one will be black, and then the rest will be white. So just making logical decisions based on what we're seeing, and maybe considering kind of the original image too. Okay, second to last row, we'll do white, white, black, and black. Middle 4 are going to be white. Then we'll have black, black, white, white. And then I think for that last row, we're just going to do all white. So we can do that. Okay, so all white for the last row. Oops, not all black, all white. Alright, so at this point now we can take a look at our original image and our digital image side by side. And it actually doesn't look too bad. I mean, obviously it doesn't look perfect, but it definitely looks a lot more recognizable than our first image. So again, for this one, we had 12 by 16. So how many total bits were needed? Well, we know that if we have 1 bit per pixel, it's going to be the same thing as the dimensions. So 12 times 16 is going to be, 192. So 192 bits for this one. This one probably took a little bit longer, maybe like 10 minutes, simply because there were more pixels to actually go through. How does the new digital image compare to the one from Challenge A? It looked a lot more like the original image. And what effect did taking a larger number of samples have on the image? Taking a larger amount of samples made the image higher quality or higher resolution. So I looked closer to the original image because we were able to kind of like represent these curves a little bit more. I already kind of answered that before. Alright, so for Challenge C, this is one that you're going to do on your own. So for this one, you're going to choose your favorite company logo and you're going to go on to this next guy here. And if you have graph paper at home, you can feel free to draw it out. Or if you just have regular paper, you can feel free to do that too. You can feel free to like annotate on this if you want to, but I'm not going to check your image in here. I'm going to be checking your image in Challenge C. So what you're going to do is you're going to decide on anything that you want to draw. Here it says a logo, but if you want to draw something else, that's fine too. So you're going to choose something that you want to kind of reproduce in the pixelation widget, and it's going to be totally up to you what resolution you want to make it. So obviously if you choose like a lower resolution, like 10 by 10, and you're choosing something that's a very curvy image, it's not going to look very close to the original as we saw with our goose image. If you're trying to reproduce maybe like an old video game character, sure, it might work out. But you can choose, you know, to do like higher resolution, like 100 by 100. That's going to be like a lot of pixels, so that might take you a long time. So maybe choose something, you know, a little more realistic. Maybe 10 by 10 is good. So if you use, I don't know, like the Chrome logo or something, you could do something like that, or some people did like McDonald's. Then what you would do is just kind of like Google an image for that. So let's say I'm gonna do, let's say that I'll do the N64 logo. I would take that, and obviously, you know, we don't have color, so maybe I'll even choose a black and white image. And what I would do is I would choose, you know, how I'm going to split it up. How many pixels wide and how many pixels high am I going to do? And then I can kind of like, you know, draw a grid over it. Or if you're doing it at home, you can try to do this, you know, on a piece of paper as best as you can. But I would, you know, try to do like a grid. You know, if I had, you know, a better program than this, I could make straighter lines and kind of decide, you know, how many samples am I going to do? And maybe I just want to do the N and not necessarily the Nintendo 64 part, because that might give me better results. And so then I'd, you know, kind of start doing that. Maybe I'd start from this row to kind of omit this part, so that I could have white, 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 probably all the way through, and then maybe down in here I would have some blacks, black pixels. I just try to see how closely I can reproduce it with a given resolution. So this one you're going to do completely on your own with the image of your choice. So obviously if you choose a simpler image that doesn't have a whole lot of curves to it, you'll be a little bit more successful in your reproduction, which is why they probably recommend that you choose a logo instead of something like a piece of art. All right, so in order to get full credit for this assignment, what you want to do is you're going to press submit on the Google Classroom assignment, this one right here, the black and white, and already you should have the activity guide filled out from this video. And then the second thing you need to have done is the rest of these exercises. So 7 is what I just explained, where you're going to create your own logo or reproduce a logo or a simple image of your choice. And then there's these check for understanding questions. So let's go through these check for understanding questions together. Assume your friend just sent you 32 bits of pixel data, or in other words, just the zeros and ones for black and white pixels that were encoded after sampling an image. Choose the two statements that are true. Okay, so remember, it's just 32 bits. It's just a sequence of zeros and ones, not necessarily formatted in any way. Okay, so what it says here is the 32 bits of pixel data is enough to produce the image using the widget. Nothing else is needed. I'm going to say, you know, this sounds really good, but what about the dimensions? Do I know how many pixels across and how many high that I have? That's really important to know, because I want to know, you know, how long are my rows? When should I go to the next row? I don't necessarily know that if all I have is a sequence of zeros and ones. So I'm gonna say, you know, probably not this one. The next one says the digital image would be an exact copy of the analog image. This is not necessarily true. So analog image is the original image, and as we saw, the goose image that that we created digitally, so the digital image that we created of the goose did not really look like the analog image. So I'm going to say that this one's probably not true either. I'm actually crossing that one out because I'm more sure of that one. The next one says that the correct width and height must be input into the pixelation widget. Yes, absolutely, right? Up here, we didn't have those width and height, so we probably not this one is what I said. But here they acknowledge that the width and height is important, so I'm going to say yes on that one. And then the fact that only 32 bits were used to represent the image indicates relatively large sample squares were used. So what they mean is that, you know, if my original image of, you know, my goose, which looked, I can't even remember what it looked like now, like he was kind of looking like that, and then he had feet out, right? If my squares are super big, like say I only split it up into 4 squares, that means that my image is not going to be very clear. I'm just going to have like maybe It's just all white here, right? And that's not going to look like the goose at all. So they're saying that, 32 bits means that their squares are going to be pretty big too. And so the digital image may vary from the analog image significantly, meaning that the digital image that you try to reproduce is going to be a lot more pixely than the original analog version. And so that is also true. Okay, so I know for sure that now that this one's not good, right? Because we needed the dimensions here. All right, so to recap, these are the two answer options that I think are best. And hey, what do you know? I'm correct. All right, so for the next one, which of the following would result in a better digital approximation of an analog black and white image? So remember, analog means the original that has all the details, right? All the different curves and intricacies. So which of the following would result in a better digital approximation? Let's see what our answer options are. So increasing the size of each sample square. So that means we're decreasing the number of samples taken. Remember, if we decrease the number of samples that we take, that's a decrease in quality. The more pixelated we're going to get. So that's not necessarily going to result in a better digital approximation. So I'm going to say no, thank you to that one. The next one says decreasing the size of each sample square, thus increasing the number of samples taken. So the more samples that we take, the higher quality. So I'm going to say yes to this one. I'm going to say, yeah, that's a good one. And then using fewer bits to represent an image. Well, if we have fewer bits and each bit is essentially being used to represent a pixel, that's the same thing as lowering our sampling rate. So that's also going to be lower quality. So that's not going to make a better digital approximation. And last one, using decimal numbers to represent each pixel. No, I don't think that's right either. I mean, it's not really going to matter if we use a decimal number representation because it's still going to be translated to binary in the end because that's what computers use. All right, so it looks like maybe just this one. We will submit, and that looks good. All right, so finally, we have a reflection. So your computer science teacher asks you to sample a black and white image that is 4 inches by 6 inches. Okay, so this is, just picture like a physical image that is 4 by 6 inches. How would you sample the image to provide a good digital approximation using the pixelation widget? What sample size would you use, and how would your decision affect the digital representation? Okay, so let's pretend that we have an image that is let's say that that's 4 inches, and this is about 6 inches. Okay, so one thing you could do is represent each inch by a pixel. So then you would have 4 by 6 pixels, but that's a pretty small sampling rate, right? You have really big squares or pixels, right? So you would have 4 high and then 6 across. Those are pretty big squares, right? But if we kind of like multiplied each side by 2 or 3 or 4, these squares would become smaller. So if we change this to 12 and this to 8, we still have the same, width and height ratio, but we're just making our sampling sampling rate higher, and thereby making these squares even smaller, just like what we saw in the goose example. And so our quality is going to go up. And then again, if we, multiply it again, we can have smaller pixels still and have even greater quality. So how would I answer this? How would I sample the image to provide a good digital approximation of the pixelation widget? What sample size would I use? One thing that I might want to consider is like how detailed is the image also? Are there a lot of curves or is it pretty blocky? Because if it's pretty blocky already, like, you know, an 8-bit video game character, I might not have to use this higher sampling rate. So how I would answer this is I would start by representing each inch with a pixel. In other words, I would set the width to 4 pixels and the height to 6 pixels. If this resulted in very low quality, I might multiply the amount of pixels per inch, amount of pixels I used to represent each inch of the image. So in other words, for example, perhaps, so we could do maybe like 16 by 36 because that's multiplying each dimension by 6. And so now you're having like a higher sampling rate, which would allow you to put greater detail. So as long as your width and height in the pixelation widget is a multiple of these dimensions, it should work out because you're preserving what's called the aspect ratio. The width and the height have the same ratio, and so you're not going to have an image that's stretched or squished together. So I think this is a really good answer because you're kind of acknowledging that you know the relationship between pixels and the actual dimensions of the original image. All right, so then once you submit that and you have all of these, all of lesson 7 lit up in green, so that's including the one that you're doing by yourself, which is exercise 7, then you can go ahead and submit this on Google Classroom and I will check the document and your code.org account.